So now one thing that I know is that the hemihydrate reacts with water to form dihydrate. Hello everyone, I am Dr. Riddhi Lalan, author of Dental Material Mind Map book and a prosthodontist who is going to teach you about gypsum in detail. So like we have been discussing in the previous classes, we now know what happens at the microscopic level, how do we actually manipulate the gypsum product, and what is the reaction that goes around. But what comes to my mind is, how do I get to know if the gypsum has set? Or is there a way that I can just increase the setting time, the setting reaction, decrease the setting time? If you are a dental student, then you have to know your gypsum product very well. You have to make gypsum your best friend. So let's discuss about how exactly can we know if the gypsum has set or not. So the first method, which is very easy and which is routinely done, is the loss of gloss. What is meant by that? So whenever you mix your gypsum along with your water, what happens? It gives a very glossy mix or a creamy, smooth texture that is formed. And once you pour it, you have to see that if the appearance is matte. So it will be the matte appearance that will indicate the initial set. At the same time, what exactly is the reaction? It is exothermic in nature. So the heat is being liberated in the reaction. So whenever you see the rise in temperature, you now know that there is interaction of hemihydrate happening with water and the dihydrate is being formed and the initial set has been obtained. But now, can there be a way that we can differentiate between the initial and final set? Not by these two methods, but the third test, which is the penetration test. Now, there are two things that we need to consider. There is Wicket test and there is Gilmore test that comes in picture. So let's just quickly see what is the difference between both of them. The Gilmore needle test actually has two weighted needles, which is going to check for the resistance of the material, while the Wicket test actually has one rotating needle that acts like a plunger. So the Gilmore test actually will show the initial and final set based upon the indentation that is caused over the surface of the gypsum. On the other hand, Wicket test is actually done by knowing the depth of penetration. This in turn will help us to determine the initial and final test. Gilmore test sees the indentation while the Wicket test actually sees the penetration. This needle that you see here will penetrate. Now, what is very important is for you to learn the diameter and the weight of the needle at the same time, the larger diameter and the smaller diameter. This is important when we talk need point of view. There can be an MCQ, and you know, whenever there is numerical, you don't have any guess that can work. You need to know your figures well. One way to remember Gilmore and Wicket test would be Gilmore. There is more to it, right? So there's more needle that is present. If you know there's two, what will come to your mind? That there were different diameters and weight. So it is weighted. And Wicket, on other hand, actually has just one rotating needle that is going to go deep, and the depth of penetration will determine the setting. Now, let's just quickly see that if at all we can modify the rate of reaction. One would be that there is some alteration in the manufacturing process. So you do everything appropriately. Correct water powder ratio, correct spatulation time, correct temperature, and still you see that some material takes a lot of time to set while other just sets very quickly. Did you do something wrong? No, that might not always be the case. There is a manufacturing processing error that can also be accountable. What exactly? It can be incomplete calcination that leads to faster set, or there is some amount of dihydrate that is already present. So we know dihydrate immediately precipitates. So this precipitation can lead to faster reaction At the same time, there is excess soluble anhydride that is present, excess natural anhydride that is incorporated into the composition, or finer particle. So finer the particle, faster will be the set because faster it will dissolve. Other thing that would be under our control would be the mixing and spatulation time. So longer and faster that you mix your water and powder, faster is going to be the set. Then water powder ratio. So more the water powder ratio, more is the setting time. So which gypsum product is going to have the highest setting time? Yes, it would be type 1. And temperature. So now we know that it is at 37 degrees Celsius that the rate of reaction is appropriate. If at all the temperature is increased, what happens? The reaction decreases. So if the reaction decreases, the setting time prolongs. So if you want to prolong the setting time, what you need to do is just use some amount of warm water. Now, we were talking about modifiers in the previous lecture, right? And these are very important when you are actually attempting your NEET or your Viva. So what does the accelerator do? It actually decreases the setting time. It fastens the reaction. It accelerates, right? They are accelerator. What is going to happen? You can use finely powdered gypsum. We just saw it can be a manufacturing error, or at the same time, you could also use a finely powdered thing. Now this usually the consistency is powdered. You cannot further reduce the size by yourself. So it is one of the methods that you can check for the particle size at the time of purchasing itself. But apart from that, you can use slurry water. Because what is it going to do? It's actually going to provide more nuclei for crystallization. Faster is going to be the precipitation of dihydrate. At the same time, low concentration of sodium or potassium sulfate makes the nucleation process faster, which leads to making hemihydrate more soluble by actually precipitating dihydrate faster. So this is the accelerator. Now when we talk about retarder, there are a number of products that can actually retard the reaction or lengthen and increase the setting time. These can be using borax, because it leads to coating of borax and the water does not come in direct contact with hemihydrate to convert it into dihydrate. So what is going to happen? It's going to take more time. So it will prolong. At the same time, low concentration of sodium chloride, about 3 to 20% is enough to actually precipitate and poison the nuclei of crystallization. Similarly, acetates, borates, citrate, tartrates, what is it going to do? It's actually going to inhibit the growth of dihydrate. Now, if dihydrate is not being produced, it will not precipitate. So the action is going to be prolonged. And colloids. Now, colloid also function with the same way of nuclei poisoning. I hope you were able to understand this. And if you want to purchase the book and go through the entire topic all at once, you can use the code Dr. Riddhi that is being flashed on the screen here, which will help you to get extra discount. So let's now solve the flashcard. Gilmore needle test versus Wicket needle test. I hope you'll be able to easily tell me the key difference. It is used to measure the initial and final setting reaction. Gilmore has 2 fixed weighted needle while Wicket has 1, and it is measured by the depth of penetration of single movable needle, while there is indentation that comes in picture for Gilmore. Moving on to the MCQ. Which of the following substance acts as an accelerator? So accelerator was just one. Can you tell me? Yes, it was sodium sulfate. But can you answer how exactly was the acceleration of reaction happening? What was being done? The nuclei of crystallization increased, which made hemihydrate more soluble, which led to more precipitation of dihydrate, leading to faster set. So this was all about gypsum, the methods of seeing the setting reaction and the factors that can be used to alter the reaction. If you really enjoyed learning this, don't forget to like this video, and in the next video, let's just understand about the setting expansion. I'll see you soon.